Okay, so hello everyone. In the last two videos, we learned how to solve higher order differential equations using two methods. Okay, the first method is methods of undetermined coefficients, and the second one is variation of parameters. So I think we're now ready to solve its applications. Okay, so application problems. Okay, so in this video, we will solve one problem. Okay, so this is our problem. Suppose a spring has mass m and spring constant k, and let omega be equal to square root of k over m. Suppose that the damping constant is so small that the damping force is negligible. If an external force f of t is equal to Fo cosine of omega o omega o t is applied where omega o is not equal to omega, use the method of undetermined coefficient that to show that the equation of motion is described by this function. Okay, so in this problem we will use the method of undetermined coefficient. Okay, so are you now ready? Okay, so let's start solving this problem. Okay, so we have here this equation. Okay, so mx prime plus kx is equal to f of o cosine of omega o t. Okay, that is our equation. We know that this is equal to d squared x. Okay, so this is another form of writing the second degree, okay, derivative. Okay, so this one, and in the problem it is mentioned that wo is not equal to w or omega. Okay, which is our omega is just equal to k over m. Okay, so to solve using the methods of undetermined coefficients, we need to find first the roots. Okay, so we have here mr squared plus k is just equal to 0. Okay, so if we solve this one, okay, we can have these roots. Okay, we have these roots r, which is equal to, okay, plus and minus square root of k over m I. Okay, so this will be our root. Okay, which is equal to wi. Okay, plus and minus wi. Since our omega is equal to k over m, we substituted it here, so it becomes omega of wi. Okay, so next is we can now form our yc or y complementary. Okay, since we have conjugated roots, so our yc is of this form. Not yc but x of c. Okay, we'll use x because we are using x here. Okay, so x of c is just equal to c1 cosine of omega t plus c2 sine of omega t. Okay, so this is our complementary function. Okay, since we know that our omega is not equal to omega o, we can now we can use this function as well to find our x particular, okay, or our particular integral. Okay, so we can have this guess x of t is just equal to a cosine of omega t, okay, omega o t, since omega and omega o is not equal, okay, and plus b sine of omega o t. Okay, so this is our x particular, our guess. Okay, so we need to find the values for a and b. Okay, so I have here a discussion about this one. Okay, so this one. Okay, x of p, we let x of p a while ago to be equal to a cosine of w of t plus b sine w of t. Okay, so in methods of undetermined coefficients, we something like find the second derivative of this one, okay? Second derivative of this one, and substitute it with our original equation. Our original equation a while ago was this one, right? Okay, so we get x of prime, which is equal to this, okay? This something like whole term is our x double prime, okay? And this one is our x. Okay, so we substituted it here, and let it equal to f of o is equal to cosine w of t. Okay, so since we can simplify this further, okay, so we got here a times k minus m w squared, which is equal to f of o, and b, okay, here. So we can now get the values for our a and b. So we can conclude that in this equation, our b is just equal to 0. Okay, substituting so like finding the value of a. Okay, we can have this value. Okay, and we can simplify this one further. Since our omega squared is equal to k over m. Okay, substitute the value of okay, factor m out. Okay, so we got here k over m, right? So k over m is just equal to w squared. So we got here w squared minus wo squared. So we got this function. Okay, this one. Okay, since we have now our values for our a and b, we can now substitute it to our original equation, to our x particular, and get our general solution for our problem. Okay, so thus, okay, we can now conclude that the motion, okay, the motion equation, okay, our motion equation is given by okay, x of t, which is equal to x of c t plus x of p t. Okay, so our x of t a while ago was just c1 cosine of omega t plus c2 sine of omega t, and our y particular, x particular rather, was f of o over m w squared minus wo squared cosine of wo t. Okay, so this is our general solution. Okay, our general solution in our particular solution. Okay, since our problem a while ago, since we wish to find the value for we need to prove that this kind of problem is just equal to this expression. Okay, so I hope you learned something and apply those concepts in our in your later part of your discussion. So thank you so much for watching, and goodbye.